Hi everyone, in this lesson we prove some more involved trig identities. So in the last lesson we looked at how to prove an identity, and we're trying to figure out how to make the left side look like the right side independently of one another. So the first thing that I do when I try to prove an identity is I break this up into the left side and the right side. The left side in A is equal to secant theta times sine theta, all divided by tan theta plus cotan theta. And the right side is just sine squared theta. So if I try to simplify, if I look at this identity, the right side is definitely simpler, so I'm going to try to simplify the left side to look like the right side. The left side, I can replace everything and try to write everything in terms of sine theta and cosine theta. So I know that secant of theta is just 1 over cos theta. So secant theta times sine of theta is just sine theta over cos theta. And I know that tan of theta is, tan of theta is sine theta over cos theta. And you should always try to get your equal signs aligned with the fraction bar, if possible. It's just a style thing in math. So tan theta can be written as sine theta over cos theta, and cotan theta can be rewritten as cos theta over sine theta. Now I could do one of two things here. I could try to find a common denominator in the denominator, or another thing that I could do is I could try to clear the denominators in the denominator of this fraction. And I could do that by multiplying both the numerator and denominator by sine theta cos theta. And if we go ahead and we do that, so we're going to multiply both the numerator and denominator by sine theta cos theta. Well, in the numerator, I would just get sine squared theta, and in the denominator, a factor of cos theta would divide out. So in the numerator, I would just be left with sine squared theta. In the denominator, I would distribute sine theta cos theta to both of these terms. So if I multiply sine theta cos theta by sine theta over cos theta, well, a factor of cosine theta is going to divide out. So I'm just left with the first term, I'm just left with sine squared theta. With the second term, I have sine theta cos theta times cos theta sine theta. So a factor of sine theta is going to divide out when I distribute this factor to that term. So I'm left with cos theta times cos theta, which is cos squared theta. And what I'm left with, because sine squared theta plus cos squared theta, using the Pythagorean identity, is just 1. So I'm left with that this is equal to sine squared theta. Therefore, the left side is equal to the right side. And I have proven this identity. In B, we are asked to show that sine theta plus cos theta times tan theta plus cotan theta is equal to secant theta plus cosecant theta. So the first thing I'm going to do is I'm going to break this up into the left side and the right side. The left side is sine theta plus cos theta times tan theta plus cotan theta. And the right side, well, that's equal to secant theta times cosecant theta. So definitely the left side is more complicated here. I'm going to try to simplify the left side and show that that's equal to the right side. Or I could try to simplify the left side a little bit and then simplify the right side to show that it's equivalent to what I simplified the left side to become. So let's go ahead and first off, let's let us rewrite. There's actually a couple different ways to do this. So first off, notice that I'm multiplying two binomials, and one way to do this would just be to go ahead and distribute sine theta cos theta, to FOIL this. And actually expand this product. It turns out that this identity works out a little bit better if you simplify tan theta plus cotan theta and rewrite that as in terms of sine theta and cosine theta first. So let's go ahead and do that. And we have sine theta plus cos theta times sine theta over cos theta plus cos theta over sine theta. Okay. So, the next thing I'm going to try to do is I'll try to rewrite sine theta over cos theta and cos theta over sine theta so that I can rewrite this as a single fraction. So I can say that sine theta plus cos theta times, this is, if I find a common denominator, I have sine squared theta plus cos squared theta all over sine theta cos theta. And I know that sine squared theta plus cos squared theta, well, that's just equivalent to 1. So I have sine theta plus cos theta times 1 over sine theta cos theta. Times 1 over sine theta cos theta. And what we're left with is sine theta cos theta, sine theta plus cos theta over sine theta cos theta. Whoops. Over sine theta cos theta. Now let's reevaluate what we're trying to do. So we've simplified this to sine theta plus cos theta over sine theta times cos theta. What we're asked to show is that this is equal to the right side, which is secant theta plus cosecant theta. Oh, whoops, and I think I did not write this properly. This should be secant theta plus cosecant theta. So this should be, whoops, this should be plus cosecant theta. Okay, there we go. So I have to somehow show that this is the left side is equal to the right side. And we could just rewrite the right side here as, let's rewrite the right side as 1 over, secant theta is equal to 1 over cos theta plus 1 over sine theta. Let's see if this makes it a little bit more obvious what we have to do here. Well, looking at it at my right side written in this form, it's a little bit easier to see that I didn't really need to even I could have left this expanded like this, but one of the things to note is that in the last step, when I distribute 1 over cos theta sine theta into sine theta plus cos theta, is that if I multiply sine theta by 1 over sine theta cos theta, a factor of sine theta divides out, and I'm just left with 1 over cos theta when I multiply this term times this product. When I multiply cos theta times this product, times this fraction, I get cos theta over 1 over sine theta cos theta, so a factor of cos theta is going to divide out. And what I'm left with is just 1 over cos theta plus 1 over sine theta as required. So therefore, the left side is equal to the right side, and I have proven this identity. The next two identities are a little bit can be a little bit tricky. In C, we're asked to show that tan theta minus 1 over tan theta plus 1 is equal to 1 minus cotan theta over 1 plus cotan theta. So the first thing I'm going to do is break this up into the left side, which is equal to tan theta minus 1 over tan theta plus 1. The right side, well, let's see, the right side is 1 minus cotan theta over 1 plus cotan theta. Okay, so let's try to figure out what we're doing here. Well, here I could make some substitutions and or I could rewrite tan theta as sine theta over cos theta, and I could rewrite cotan theta as sine theta over, or sorry, cosine theta over sine theta. But really, the left side is written in terms of tan theta, and I know how to write the right side in terms of tan theta. So let's just go ahead and we'll try to do that first. And then if that's giving us all kinds of a big headache, we'll just reevaluate our strategy, we'll erase our work, and then we'll just try a different strategy. So sometimes identities are kind of like working through puzzles. You have to try them a couple times before you are able to figure them out. So let's rewrite the right side. And the right side I can rewrite as 1 minus 1 over tan theta. And I can rewrite 1 plus cotan theta in the denominator as 1 plus 1 over tan theta. Now, what's bothering me here is this pesky tan theta in the denominator of this term and the pesky tan theta in the denominator of this term. So one thing that can help with that is notice that I can use the trick of multiplying both the numerator and denominator by tan theta. And when I do so, I'm really just multiplying this whole fraction by 1. So I'm going to multiply by tan theta over tan theta, which is the same thing as multiplying this entire thing, this entire fraction by 1. So I haven't changed the value of the fraction. When I distribute this factor of tan theta to the numerator, I get tan theta minus 1. When I distribute tan theta to the denominator, I get tan theta plus 1. And the left side is equal to the right side. So therefore, the left side is equal to the right side. So that identity wasn't too bad, but definitely if you there's a chance that you could get stuck on this one because you might you might overlook this trick here. Okay. So for D, we've got cos squared theta over 1 minus sine theta is equal to 1 plus sine theta. So here there's definitely a trick that I'm going to show you. So the first thing that we're going to do to start out this identity is we'll just, again, break this up into left side and right side. The left side is cos squared of x over 1 minus sine of x. And the right side is equal to 1 plus sine x. So the first thing that we'll do is we can rewrite the left side in terms of sine of x. Cos squared of x can be written as 1 minus sine squared x over 1 minus sine of x. And the right side is going to stay the same. So what I need to show is I need to show that 1 minus sine squared of x over 1 minus sine of x is equal to 1 plus sine of x. Now, there's a really important thing that you can't miss in this problem, and that it's that 1 minus sine squared of x is a difference of squares. And remember that for a difference of squares, like let's say you have a squared minus b squared, Well, a squared minus b squared can be rewritten as the conjugate, as the product of the conjugate pair a plus b times a minus b. So if you miss that, then this problem is going to be, maybe a little bit more difficult. And but if you realize that 1 minus sine squared theta is a difference of squares, it's really, really easy to solve. So we can rewrite 1 minus sine squared x as 1 plus sine x times 1 minus sine x, all divided by 1 minus sine x. Now, these factors of 1 minus sine x, they divide out. So those factors divide out. And what we're left with is 1 plus sine of x, which makes the left side equal to the right side. So I can write my therefore left side is equal to the right side. And I have proven this identity. And just something to note again is that here, this identity really only holds if sine of x is not equal to 1. That means that x can't be 90 degrees. X can't be any angle that is coterminal to 90 degrees, actually. So there's limitations to this identity. Because obviously if sine of x were 1, then I would have division by 0, which is undefined. That would mean that the left side would be undefined, and the right side would be 2. So that's obviously can't be true. So that you'll deal with in the advanced functions course. And those are restrictions on the angle x.